So today we will continue from the last slide that we had about cross-sectional and longitudinal. We had discussed about, just to recap, in your research design, we had discussed about the exploratory research design. We have discussed about the descriptive research design. In descriptive research design, we have also discussed about basics of your cross-sectional and longitudinal. Now, another a very important types of research design is when we have to test our hypothesis, or you can say that when you have certain variables which are interconnected, influencing each other, then you need to look at the relationship between those variables. That means if X variable is connected with Y, so to what extent X is affecting Y, or Y is affected by X. So we need to look at this causal effect relationship, cause effect relationship, and that is why sometimes it is also called as a causal research design. And to look into this relationship testing, say for example, we can also say that X is affecting very positively the Y factor. So this is basically an assumptions based on maybe past studies, maybe based on your experience, maybe based on your exposure. So you pre-assume a statement. Say for example, if you pre-assume a statement that if there would be too much of summer, then there will be high rain in coming season. So some says that if you have very cold weather, very hot weather, then you will have more than average rain. So you can make this statement, you can assume it. Now you need to test it. Say for example, if you will eat fried food, you will have constipation. So fried food is having effect on your stomach health. So you make an assumption. Now you test this hypothesis. Now yes, you can test this hypothesis by two ways. Either you observe it, you eat fried food, and then see your health. Now you may say that when you eat in morning, you do not have any severe effect on your stomach. But if you eat in evening, then you have an effect. So you get some constipation, or you some get acidic problem or like that. So these are certain factors, morning, evening. These factors may be called as extraneous factors. We have already discussed about those things. My point here is to make you understand experimental research design. Experimental research design is basically used for testing any hypothesis. Say for example, someone says that whenever I take paracetamol, I feel some awkward behavior. Now if this is hypothesis, so you need to test it. You can test it by experiment. Experiment means take paracetamol and then see result. Say for example, someone says that if you will give proper watering to your plants, so they will have a good yield. Now this definition of proper, it is not the maximum watering. It is not the it is basically suitable level of watering. So point is, these causal effect relationship can be tested only in experimental research design. Now this experimental research design, you know, since you are directly testing your hypothesis, so this type of design gives you relatively a better picture of your you know understanding, and you can make better decisions. If we talk about in marketing sense, like we say that suppose you have to study about the performance of a particular product in a particular market, then obviously you will set experiment. We'll take in coming slides, but before we just look into this, there are two types of experimental designs. One is informal experimental design and other is formal experimental design. Now in informal experimental design, you have the main key point as a control. Control design means in some part of your design of research, you give some treatment and other part you do not give. So control design means you have things with design, with control design, and second maybe without control design. So before and after experiment, you use control design. Another method, you only use after control, or you use control before and after at the both the ends. This may not be very clear at this minute, but when we will discuss this in detail one by one, you will get each and everything very clearly, so you don't have to worry about it. But before it, we need to look at that what are the different principles of experimental research design, because we will take these experimental research designs in coming lecture, maybe the next lecture. But today my focus would be that to learn the basic principles of experimental design, research design. We talked about that Professor R.A. Fisher has been a name in experimental research design. Actually, he was an agricultural scientist, and while conducting experiments with the agriculture yield, he came on conclusion with the he established certain principles, and those principles later on, based on scientific facts, became the core principle of research experimental design, and started people started using those principles into normal technical research design, market research design, or industry product design, or in almost every field. Professor Fisher enumerated three principles of experimental research designs. One, principle of replication. Another, principle of randomization. And third, principle of local control. So in today's lecture, we will try to make focus on these three principles. And in next, we will try to cover all those informal research designs and formal research designs. So that may require at least 2 lectures maybe. So what exactly first principle talks about? Look at this. Principle of replication simply talks about that if you want to study a causal effect relationship between two factors, or a relationship between two factors, then you need to repeat the experiments more than once. That means, say for example, if I say that uh, A is a particular in terms of Professor Fisher. Professor Fisher conducted this experiment that a particular A brand rice and a different B brand rice, two types of rice, and the yield of these two types of rice in a particular field. So what he did, he divided that field into two, and half the field he used for A rice, A type of rice, and half the second type of rice, B. And then he got some data that yes, the yield or productivity of A brand of A type of rice is this, and B type of rice is this. So he was in position to establish that what is the productivity or yield for A rice and for B rice. Now, when you talk about the experimental design, because it may be possible that productivity of A is higher than productivity of B, possible, quite possible. But the thing is that reason may be that you say that this part of your land or field is having more fertility or soil quality, very high quality of soil or soil fertility, and this part is having low fertility, you may say. So just to ensure and remove the errors, principle of replication says that it is not that you use this field for A brand rice, rather you repeat the experiment. Means you make 4 subgroup of this half of field, separate it, then you check the yield of A brand in this, then second, then third, then fourth, or you say, see, you used all these 4 fields for A type of rice and these 4 for B type of rice. Now it simply means that instead of getting one data for one field half once, you may have 1, 2, 3 and 4 data, and likewise 1, 2, 3, 4 experiments, and this way also 1, 2, 3, 4 experiments. So the result or the data which is replicated maybe in similar situations, that can give you a better picture, better result on average it, either average it out, or using another method you can ensure that the statement or hypothesis or your causal effect relationship, that can be ensured in a better way as compared to this. So say for example, you say that for example that you talked about that all the Chinese people, they are shrewd. Now how come to know that a person is talking to Chinese person, one Chinese person, and his experience says that Chinese people are shrewd. Now this may be having biased output. So your experiment is based on one experiment. So just to reduce that biasness and ensure more better result, a person is talking to first Chinese person, second Chinese person, third Chinese person, fourth Chinese person, meant replicate the experiment more than once and then draw a conclusion that whether Chinese people are shrewd or not. And as compared to this, African people are very cooperative. So one experiment cannot give you a better result. Rather, you replicate it 1, 2, 3, 4. And then B person talks about 4 different people of South African continent. And then conclude whether South African people are cool or not. That means you can conclude by experimenting, and the experimentation must be repeated more than once, and this number of repetition, more the repetition, more the accuracy you will reach closer to. So it becomes very important to understand that principle of replication talks about that minimizing the biasness or the errors. Now second principle, which talks about the principle of randomization. Now why talk about principle of randomization? Because look at this, maybe that when you are talking to these 4 Chinese people, right? So it may be possible that when A is used for analyzing causal relationship with this one, with this one, with this one, with this one, there may be some extraneous factor. Say for example, we talk about the Professor Fisher's experiment. Fisher further elaborated that if A brand rice is checked in this field, in this field, in this field, in this field, and then yield comes, and likewise B brand here, may be possible that this half field is very much influenced by high fertility soil, and this may be having low fertility soil. So this soil fertility is basically an extraneous factor which may affect your causal relationship. And you may say that A rice is having high productivity as compared to B, but this result may be based on high fertility of soil, and B may be based on low fertility of soil. So your experiment may not give you very correct result. So randomization, principle of randomization used to provide protection when we conduct an experiment against the effect of extraneous factors by randomization. By randomization means if you are using A brand rice for this, so you can randomize it. B brand rice from here, B from here, A from here, A from B from here, A in this field, B in this field, A in this field. So this way, the factor, extraneous factor here in this case called soil fertility, that the quality of soil, that may be reduced to certain extent. And when data of A yield of A brand rice and yield of B brand rice, so you will be in position to compare it in a better way whether A brand rice is giving you good output of production or productivity or yield or B. Take another example. Say for example, I say that A product, this is whole Kanpur market, right? and you have to decide about you have to get that data that how A product performs and how B product performs. So if company says, say for example, that our A product will perform better than B product in Kanpur market, right? Now this is hypothesis, and that you need to test. For example, that A product performs better than B product in Kanpur market. Now look at the case. When you say that A product performs better than B product in Kanpur market, so principle of replication simply says that you divide this Kanpur market into North or South Kanpur. In North Kanpur, it may be Kalyanpur, this may be Nawabganj, this may be Swaroop Nagar, or this may be your Kent area, and where they talk about Barra, Kidwai Nagar, and all those Kanpur South, right? Now, what at all you are doing? If you are testing A product in this north region, Kanpur, and B product in this region, so you can say that A product is performing better than B because of this extraneous factor that this market is basically Swaroop Nagar market, Kent area market, or Kalyanpur market, which is, the customer is having paying ability and their living standard is high and this and that, as compared to your Kidwai Nagar, Barra, or South Kanpur. So just to remove this extraneous factor of this living standard or demographic profile, if you make it randomized, that means you test A product in Swaroop Nagar, but nearby Kalyanpur you test B product. Then maybe that in Kent area you test B product, and in Barra you test A product. And then, Kidwai Nagar you test B product, and then, another zone of South Kanpur you test A. So this way, when you randomize this, so you get the data of A product performance in different, parts of Kanpur, which may not have randomized. That means this you are not choosing. You are choosing randomly. So when you choose randomly, so you cannot say, you can minimize the extraneous factor of living standard, or cost of living, or paying ability, or you can say demographic profile, customers demographic profile. So if you want to test whether A product is doing better than B in Kanpur, or A product will do better than B in Kanpur, maybe A and B both are biscuit brands, or maybe A and B are different car brands. So if you want to test this A performs better than B product in Kanpur market, so your randomization, this randomization, principle of randomization talks about that you make so many parts of sub market or sub segments, and then experiment the products in random way, not a systematic way, so that you can minimize the effect of extraneous factor in market case, that may be a demographic profile, living standard, paying capacity, or you can say it may be any extraneous factor. So point is very simple, that you must follow this principle of randomization when you are, because this principle of randomization can make you to go closer to the real result or output, and you can better test your hypothesis. It is not that you go to only Swaroop Nagar and you talk a few customers and you decide that yes, Kanpur market is not good for this particular product. You need to repeat experiment first. Second, you need to randomize the area of experiment or survey. Now, the third principle which Professor Fisher talked about, that was that the extraneous factor, maybe that we talked about in agriculture, like soil fertility or quality, or in market case, it may be your living standard, it may be demographic profile, any parameter. The extraneous factor, the known source of variability. Variability means if high productivity is coming for a rice brand, so this may be there may be variability because of that soil fertility. So local control means, they say, Professor Fisher was of the opinion that you make this variable extraneous factor deliberately. That means you deliberately conduct your experiment where extraneous factor is available and you know it. You take into consideration, but at the same time is made to vary deliberately over as wide range as necessary, and this need to be done in such a way that variability it causes can be measured. Look at it, this thing is very important. The variability, you can say that yes, the soil fertility can affect your productivity, increase your productivity by 10%. So this variability and you can measure it, that yes, if it is Swarupnagar market, so the production, the high luxury car will perform better than in some Barra area or like that. Now you need to make local control, nullify this extraneous factor. So if you know that the soil performance or the earning capacity, the average per capita income of Swarupnagar market is, say for example, 1 lakh rupees per person, per family, and the per capita income of Barra area is 60,000. So you can very easily measure it, that to what extent this per capita income will have impact on this extraneous factor will have impact on this cause relationship. So if it is 2 times in some way, so you measure it, and with that measurement you eliminate the experimental error. That means if per capita income is 1 lakh here and per capita income is 60,000 there, so this data you get it, you can measure it. So you can measure that to what extent it will impact on causal effect relationship. So that data error you can correct, and this is called local control. That means when you are in position to measure the variability of extraneous factor, then you can control it. That means you can control the error, to what extent that error can go and change your level. So these 3 principles are very important to understand, and in my continuous lecture in next class, I will start from this particular informal experimental design, which will be before and after without control design, then after control design, and then before and after with control design. So we'll try to cover these topics. So I'm just closing my lecture here.